Yeah, hi guys. This is going to show you how to solve rational equations and discuss inequalities as well. Sorry, there we go. We're going to solve these two rational equations. Rational as in ratio, as in fractions. And then we're going to change it to inequalities down the bottom. Same equations, just change the equals to inequality and see what difference that makes. Let's start with this one on the left. Okay, so when you're adding fractions, you got to get common denominator. So common denominator here is just multiply these two together. So 4 and 7 becomes 4x minus 3 over 7x minus 3. And then 3 becomes 21 because you've got to times top and bottom by 7, etc. Okay, get the common denominators, expand brackets here, then simplify. Okay, now we've got two fractions, so we're going to do your cross multiplying. We do the 8 goes up there, and the x minus 3 goes up here, which is what we've got. Expanded brackets, get all the x's on one side, all the numbers on the other side, and then divide. And the answer is x equals 11. That's it. Okay, so we're making common denominators, we're getting two fractions that are equal, we're cross multiplying, and we're doing some simple algebra to get our answer. Okay, another example. This time a bit harder. We've got to get a common denominator. Let's start with the left-hand side. Okay, so x plus 3 times x minus 2 has to be our common denominator. So times this one by x minus 2, times this one by x plus 3. There we go. Now, guess what? X squared plus x minus 6, that's the same as x plus 3, x minus 2. Look at that. All three things have the same denominator. So that means we can just ignore the denominator for now. Okay, so the numerators add up to 122. Okay, expand the brackets, simplify, get all the x's on one side, numbers on the other, and divide. X equals 5. Okay, all that big mess there means x equals 5. Okay, so again, common denominator, cross multiply or cancel, and then simplify, simplify, simplify. Okay, that's solving rational equations. Okay, hopefully there's skills you already have and you are able to do that pretty well. Taking it to the next step, we're going to do rational inequalities. So here's the one we did before. So we have equals. Now if we have a less than sign, we just do it exactly the same way to here, and then because we got the x on the other side, we'll just flip it all over, and then x is greater than 11 is our answer. So that's inequalities. But is that actually the answer? Let's have a think about that. So you do all the work, get to x is greater than 11, but you have to think x can't be equal 3. So there might be something else going on here. Let's check the different regions. So I think about what happens at x equals 3, where we've got a vertical asymptote, and x equals 11, where we have our intercept, or our critical point here. So what happens when we're less than 3, when we're in between 3 and 11, and we're greater than 11? Well, do some test points. Try them out, see what happens. And what we see is, when x is less than 3, the left-hand side is less than the right-hand side. When we're between 3 and 11, it doesn't work. When greater than 11, as we suspected, it does work. So what's happening is x is greater than 11, definitely, but it's also x is less than 3. Okay, what's going on here? How does that work? If we graph it, if we graph the left-hand side here, that's the red one, and the right-hand side here is just a constant, so it's just a horizontal line. And you see there they intersect when x equals 11. So they intersect in x equals 11. Now we're asking less than. So when is the red one less than the blue one? That is, when is it underneath? Well, it's underneath over here. It's underneath from 11 onwards. So when is the red one underneath? There's a red one underneath the blue one. That's when x is less than 3 and when it's greater than 11. Okay? Bit of a tricky concept there. Go back and rewatch that example if you want. One more example. Well, this is what we did before. We solved this whole thing and we got that x is less than or equal to 5. But can't be equal to negative 3, can't be equal to 2. And this is important because both those numbers are actually less than 5. So let's check the different regions. We got less than negative 3 equals negative 3, between negative 3 and 2 equals 2, between 2 and 5 equals 5, greater than 5. So let's see what's happening. When x is less than 3, if you put the number in here, you will get a true statement. If you put a number between negative 3 and 2 in here, you get a false statement. True, false. Okay, so we can see that it works for less than 5, but only to 2. And then between 2 and negative 3, it's not true. And then less than 3, it is true. Okay, so the actual answer is x is less than negative 3 and between 2 and 5. It can be equal to 5, it can't be equal to 2. It can't be equal to 2 because 2 is an asymptote. What does that look like? What does that mean? Okay, again, left-hand side is orange, right-hand side is purple. Here we've got a less than or equal sign. So when is the orange underneath the purple? Well, over here it's underneath, so that's less than negative 3. And above, from this line here, from the asymptote up to 5. So there it's underneath. Okay, so there are 2 times when the orange is underneath the purple, and that's what your answer has to reflect here. Okay, again, pretty solving, not too hard. The inequalities, bit of a few things to think about there. So go back and watch it again, see if you can work it out. Try some more examples. Try it with a table like this. Try it with graphing. See if you can make the connections. Just a bit of a summary. Rational equations, just get common denominators, do cross multiplying and cancelling. If they're rational inequalities, solve it like an equation, then look for your important points, your discontinuities, your asymptotes, your intercepts. Look at the table of different intervals, test points, and write an answer. So check it by graphing. Okay, might be a bit of a challenge, but have a go. Come back and watch this again, see if you can work it out. Good luck, people.